All right, then, welcome to Remote Learning 20, Part 2. And this is going to be the first of 3 final exam reviews. Don't let the black background and red lettering scare you, because it is going to be a modified final exam. It's worth 7% of your overall grade, and it only covers the last chapter that we did in full. That was chapter 9 and a tiny bit of chapter 10. Okay, so we're going to take 3 half hours and roll through the final exam review. This is the first installment. It's the opening few sections of chapter 9. So chapter 9 was a big chapter in the sense that it developed for us the famous quadratic formula, which is really a way of solving any second order equation. It's that jumper formula that we created by completing the square, but we did do a few things first. The first thing we did was we had to get really familiar with how to manipulate square roots, or for that matter, manipulate radicals, whether they be square roots or cubic roots or fourth order roots or whatever. Okay, so I'm going to take you back to some of the technical details of the opening section, as we needed those technical details to work our way through the rest of the chapter. All right, then. So this is 9.1, and it is properties of radicals. All right, so I've got 5 problems here that I think will do the job. And this first problem is immediately getting us into a 3-for-1 trading scenario. So I want to emphasize that the index is the trading scheme. And so we're now going to see if we can get any triplets. All right, let's go with 27 is 9 times 3. 9 is 3 times 3. So look at that. I've got a triplet. I've got 3 3s. X to the 10th. I can make all sorts of triplets. There's a triplet of x's. Here's another triplet. And then the 10th x is right there. I'm not going to circle all of those. Okay, so then we're going to do the exchanging. So I'm 3-for-1 trading. I've got 3 3s. I'm going to take out a 3. I've got 3 x's. I'm going to take out an x. I've got another 3 x's. I'm going to take out an x. I've got another set of x's. Take out an x. And then I've got that sole x that's staying inside of the cubic root. Okay, so then wrapping this thing up, that's 3 x cubed, and 3's everywhere, times the cubic root of x. All right, so that is my first problem of the day. All right, so let's come over here and talk about some technical details around radicals. So you need to remember that it is not allowed to have a radical in the denominator. And sometimes we use a trick that looks like this. We called it multiplying by 1 in disguise. And that's what you would do if this part wasn't there. That's a great way to get rid of a radical on bottom when it's just by itself. But this 3 plus is adding a layer of complexity. So I got to remind you of something called the conjugate. All right, so this is the conjugate of 3 plus root 5. The only thing that changes is that sign right there. And we're going to multiply by 1 in disguise as this red numerator divided by itself. Okay, so now we'll just have to very carefully do all of this. And it looks like I'm going to need a little bit of room. Okay, so let's do it. And on top, I am going to distribute the 12. That's 36 minus. Now pay careful attention to this. There's lots of tricky rules with radicals. This is a non-radical 12 times the square root of 5. The best we can do is write just 12 times the square root of 5. Okay, we cannot 2-for-1 trade anything out here. And this is a radical and that's a non-radical, and then we just write them side by side. Okay, so now let's look and see what happens down here. This is a binomial times a binomial, so it's time to do some foiling. That's 9. Okay, then over here we've got a positive times a negative. That's a 3√5 situation. But then in here we've got a positive times a positive, so that's a positive, but that's also a 3√5. And finally, here is a positive times a negative. And I'll slow this down. √5 times √5 is √25. Since they're both radicals, you can put the product of them inside of the radical. Okay, so the reason that we talk about conjugates and use conjugates is because they will always create this scenario where those two pieces cancel out. All right, let's see what we get here. We've got 36 minus 12√5. Just caution you on not subtracting those two. These are not like radicals, so they cannot be subtracted. This one's a √5 and this one's not. And then over here I've got a 9. This is the minus sign, I'm writing minus, and the square root of 25 is 5. Okay, so let's see. I'm going to change this to 36 minus 12√5 over 4. And I'm observing that 4 does fit into both of these. Think about this as the divider, separator. Okay, so we've got 36 divided by 4, which is 9 minus, and then we've got 12 divided by 4, which is 3. Tack on the √5 on that one. Okay, so that's a complicated one that brought up a lot of fundamentals around working with radicals. Okay, so let's see. I think all 3 of these are easier than that one, and let's do them. Okay, so new concept over here, which I mentioned on this one, but you can only add if the radicals are alike. So it's a lot like combining like terms. You need to combine like radicals. So this one's a √3 and this one isn't. But it may be that this can be turned into a √3 by 2-for-1 trading. And they made one where that happens. Okay, so let's see what we've got. We've got 4√3 plus 5. That's the 5 there. Now, a 2 comes out and joins it, and inside the square root is this one that doesn't have a partner. 2-for-1 trading, right? Because we're looking at square roots now. The 2 is not written, but there's really a secret 2 up there, right? Okay, so now I've got 4√3 plus 10√3. A popular question back in the day was, if you take something out like this 2 and it joins something that's already out there, what do? You multiply it. Things that come out join something that's already out there, or 2 things that come out, they always get multiplied together, and things that stay inside get multiplied together as well. Okay, so final answer on this one, you're combining √3s and you wind up with 14 of them. All right, so let's pop over to this one, which is back to 3-for-1 trading. Now 2 is already prime, so I'm not going to get anywhere with that one. What is this? 9 times 6. 9 is 3 times 3. 6 is 3 times 2. Okay, so I can do some trading on that one. All right, this one was 15 times the cubic root of 2. I'm going to subtract from it 2. I do get to take out a 3, a single 3, 3-for-1 trading on account of that's the index. And then left inside of that cubic root is this 2 that doesn't have any other partners. All right, so then let's see what we got. We've got a 15 cubic root of 2 minus 6 cubic root of 2, so that's 9 cubic roots of 2, or 9 times cubic root of 2. Okay, and the last one before I move on past 9.1, we got to be careful with these binomial squares, right? What does it mean to be squared? It means that this base is multiplied by itself. All right, and then because of the plus signs, then we have to do foiling. So we'll go through this foiling process again. That's a pretty tricky one. 3 root 7 times 3 root 7. We multiply the 3's together to get 9, and the root 7's together to get root 49. This one, 3 root 7 times 5. We multiply the regular numbers together. In this case, that's 3 times 5 is 15, and then just tack on the root 7. Same thing in here. Keeping my eye on the signs. Everything's positive on this one. These are not conjugates, so I'm not expecting things to cancel out like this problem. Okay, so that's that one, and then this is plus 25. Okay, so let's see what we got. This is 9 times 7. These two merge up for 30 root 7. And then that's 25. Okay, 9 times 7 is 63. And 63 plus 25 is 88. Plus the 30 root 7. And then I'm done with that one. Let's move to 9.3. And 9.3 is a method of solving a quadratic equation. The key thing on this section, though, is that the quadratic equation is missing the x term. So we can see that here, and we can see that on this one. There is no x term. All right, now if we were to FOIL this one out, we would have an x term, but I'm going to use the method that we use in these two on this third problem and emphasize that what we're doing is we're isolating the item that's being squared and then square rooting each side. On these first two, the item is the x that's being squared, and then over here it's the binomial x minus 1. Okay, so let's roll through these three problems. All right, over here on the left, we're going to isolate the x squared component. That requires minusing 25 and dividing by 4. Okay, so now that we've isolated the x squared, we're going to, as a big reminder, it's now time to root this side and root this side as well, not forgetting to introduce the plus or minus to generate the two answers. Okay, so here we've got x equals plus or minus the square root of a negative, and then that's one of these no solution type problems. All right, just to remind you that you cannot have a negative within a square root. We'd be totally fine if that was positive 25 in there, and then we would 2 for 1 trade out the 5, and the two answers would be plus or minus 5, positive 5 and negative 5. Okay, so let's come over here to the next problem and see what we can do. So we're going to, again, isolate the item that's being squared, which is this x. And so I'm going to minus off 30, and I get negative 11. Okay, so isolating this x squared, I'm now going to divide by negative 5. And I have a double negative over here, so that's 11/5. And then, okay, that equals x squared. All right, I'm going to twist things around so that it looks a little more normal. Okay, so I saved myself a little room there on purpose because I know what I'm going to do. I'm going to root this side, I'm going to root that side, and then remember to bring in my plus or minus. All right, so over here I've got x, and then I've got the answer root 11/5. And I've also got the answer negative root 11/5. All right, now because we worked on radicals earlier in 9.1, then I'm going to do a couple of fundamental rules. I'm going to break this fraction into its two parts, numerator, denominator, and then rationalize the denominator by doing the multiplying by 1 in disguise trick. I don't have to worry about this conjugate notion that we've talked about recently because this isn't a binomial. All right, so I'm bringing into play a lot of ideas, but here we have the square root of 55 there up on top, and on bottom a regular 5, and we're done. Okay, so these moves are going to be essentially identical, but we're going to wind up with negative root 55 over 5. All right, now let's get into this last one over here on the right. The item that's being squared is now the binomial x minus 1. So I can get rid of this squared by rooting as usual. I'm going to root this side as well, not forgetting the plus or minus. And let's see what we get. So those cancel out. I'm left with x minus 1. And over here I have plus or minus 3, the square root of 9 being 3. Isolating x, I need to add 1 to each side. And then this starts to look really awkward. I'm going to write the 1 first. That's the positive 1. And then there's a plus 3 and a minus 3 version. Well, let's go get those. 1 plus 3 is 4. And 1 minus 3 is negative 2. Okay, so we've got no solution over here on account of we just ended up with a negative root. We've got two solutions over here that are awkward, but we do know how to avoid the problem with a fraction in a square root or a radical in the denominator. So those are some fundamental ideas there. These two cases are not acceptable. All right, so then I've rationalized by doing that red trick. All right, and then before I leave this section, let's do a word problem here about a sprinkler. What's going on with this? A sprinkler sprays water that covers a circular region. Okay, so this is where the sprinkler is. Maybe this is the hose. Running over to the house, and it's twirling around, throwing water. Maybe it's going this way, right? Because then we get these little patterns of water landing. Okay, so it's twirling around like this, and all right, it's covering some surface area. Grass, water, hose to the house. Okay, a sprinkler sprays water that covers a circular region of 90 pi square feet. That's an area. And I have this feeling that we're going to need the area of a circle formula, which is pi r squared. All right, not to be confused by circumference, which is 2 pi r. And so this area is calculating all of this light blue stuff. Okay, find the diameter of the circle. So we want to find the diameter, but in order to find the diameter, what I'm going to do is I'm going to find the radius and double it. Okay, so by formula, I have that the area of a circle is pi r squared, and given to me in the problem is that the area here is 90 pi. Okay, so we're going to solve for r. and then double it because they want the diameter. Okay, so maybe I'll just write that over here. Diameter equals 2r. All right, solving for r, I need to divide by pi. That's kind of convenient. R squared equals 90. Root it. This time I am going to remember to bring in the plus or minus, but I'm also going to throw out the minus because a negative radius is not possible. So I'm going to write this as plus or minus, and I'm going to kill that one off. And I have root 90, which needs to be worked. 9 times 10. That one's 2 times 5. This one's 3 times 3. That's a 3. Never can save them. Okay, so let's see what this becomes. I'm just going to not write plus out there. I know it's positive. I can 2-for-1 trade out a 3. And those have to stay inside, making 10. And okay, that is the radius. And then either radius plus radius, or we want to get the diameter. Why don't we do radius plus radius? I was going to multiply it by 2, but this will reinforce the idea of you can add like radicals. Final answer, 6 root 10. Oh, final answer, 6 root 10 feet. Okay, so this was 6 root 10. This radius is 3 root 10. Okay, so that's that one. And let me just do a quick little time check. I'm going to go ahead and do this last section. And the remaining time, we're going to go back to completing the square. All right, completing the square is really excellent process to do when you cannot factor and when there's a 1 out front, and particularly good because you get to avoid fractions when this one's even. All right, so let's see the completing the square algorithm, the step-by-steps you have in one of the earlier videos. So I'm not going to rewrite them out, but I'll do the problem. We're going to clear out the constant. That's one of the first things you do. It's either the first or second thing to do. Turns out it doesn't matter. That's 7 here. And then the next thing to do is to ensure that you have a 1 out front. And if you don't have a 1 out front, then you have to divide everybody by whatever that number is to turn it into a 1. Okay, so we do have a 1 out front, so we're good. Then it's time to go off to the side with the x's coefficient, so-called b number. Chop it in half. Take that number and square it. That's always going to be positive. And then hopefully this will jog your memory right here, just me doing this. Okay, we'll see what happens. Okay, so let's see. You take the b coefficient, x's coefficient, which is called b, you chop it in half, take the result, square it, add that on. You can't just go add it on to one side, so you add it on to the other side as well. And then you factor. And the reason I did that little box over there with the red -3 is that was our little cheat. Not only is it factorable, it factors into matching pieces. Okay, so then it looks a lot like the problem I just did in terms of it's a binomial square. So it's time to, 2 problems ago, I guess, before the word problem. But it's time to root this one and root that one. Don't forget plus or minus. And then that kills off the square, so we have x minus 3, and then over here we have plus or minus 4. 2-for-1 trading on the root 16. All right, add 3. And I've got x equals, I like to write the not plus or minus p's first. So I got positive 3, then I've got plus 4 and minus 4. Okay, so let's see, I'm just going to write it over here. That makes x equal 7, and that makes x equal negative 1. All right, one more problem, and then that's a wrap for today. Maybe I'll wrap it for today right now, so I can start the next one with a review of completing the square and then do this last little twist. I think that's what I'm going to do. Okay, so I'm going to stop it now and give you a collection of problems that will help you practice these opening sections of 9.1. All right, so then here are the opening practice problems for the final exam. This is the first of 3 sets. Of course, this is also the assignment for part 2 of Remote Learning 20. Okay, so there are 4 problems involving section 9.1. There are some 3 problems involving section 9.3. And then I'd like you to complete the square here on these 2 problems. That's 9.4. All right, come into the meets. I'm certainly happy to help you. Thanks, everybody.